our notes on inclined planes. Yes. This is going to be important.
I feel like it's the hard unit, right?
This is hard. Yeah.
Aww.
All right, so if you follow the process and you learn the process and you do the process, inclined planes are not intimidating. If you skip the process, they are overwhelming. So I want to walk you through it. The first situation that we're going to have is an inclined plane with an object in equilibrium.
I'm not. Oh, I don't like you.
So we're going to start with our plane. We have an angle theta here. We always have a theta that designates what the incline is. So the problem would say something like, we might say Clayton pushed a box up a ramp of 30 degrees. And the theta will always be right here on your inclined plane. So let's put a box here. And you tell me the first force that acts on the box.
Gravity.
And gravity pulls straight down. I'm very carefully going to draw the gravity straight down. Remember, I can call that Fg or Fw, whichever one I like. What's another force acting on the box?
The applied force.
Normal.
Who's pushing it? Ah, you're right. Clayton is pushing it. And this particular one, I didn't have him push it. I shouldn't have brought Clayton up. So we're going to take his hand. We're just snap.
Okay.
No more Clayton's hand. What else?
Normal.
Normal force. Normal means perpendicular to the surface. Now this surface is different, right? So we actually have to tilt our head this way in order to draw that normal force coming perpendicular to the surface. It's a little odd. Now the problem tells me that the box is in equilibrium. So what other force do I need to add?
Friction.
It is static friction force. I heard it from the front. It is friction force. And what would the box, which way would the box normally slide?
Down.
Down. So friction force should be up. Different than the quiz question. Talk about that one later. So there's my frictional force. So this is your legal free body diagram. If you are asked by College Board on any FRQ to draw the free body diagram, you only want to focus on the forces that are true pushes or pulls, and we didn't. Now that we're going to solve an inclined plane problem, we're going to use a different strategy. I'm going to ask you to switch colors and to draw the components of the only force that is not along the axes. Let me show you what I mean. Here is my x-axis, the axis of motion. And here is the perpendicular to that motion. Can you kind of see that? That means everybody has to tilt their head slightly to the left so that you can see the way the box slides, and that becomes your x-axis now. Okay, don't get a crick in your neck, but that's how you have to look at it. So that being said, which of the three forces is not on an axis?
Gravity.
Gravity. And because the gravitational force is not on an axis, that is the force I have to break into the components. So that means this is going to be my hypotenuse, and I'm going to break that into a force along the x-axis and a force along the y-axis. These are the legs of the triangle where Fg is the hypotenuse. Now when I label that, your book is kind enough, instead of labeling it x and y, they label it parallel and perpendicular. So I'm going to try to conform to that. Please know this is the first year in all my years of teaching that I've actually conformed. I'm trying. But that means this one is parallel, so this will be Fg parallel. And this one is perpendicular to the surface, so it is perpendicular. If you remember from geometry, those are the symbols for perpendicular and parallel. Now we're going to put that on pause for just a moment. Please know that once I take this gravitational force and I resolve it into its components, it's as if it's not even there anymore. We don't need to worry about it anymore. We've already compensated for it with the components. So now let's look at the sum of the forces in the x and the sum of the forces in the y. In the x direction, what are your two forces?
Friction and gravity.
Friction and parallel. Normally I take the big minus the little. In this case they are equal, so I'm going to do right minus left. So here we go. The friction minus the parallel force. Now we want to do the same thing for the y direction. The two forces I'm concerned about in the y direction are normal and perpendicular. So since there is not a big minus a little, I'm just going to do it up minus a down. That's a normal force minus Fg perpendicular. All right, so there's two other steps here. And the first one is going to involve a little geometry thinking. When I write theta here, it happens to be a corresponding angle with this angle up here. Remember geometry class? So let me, pretend for a moment. This big triangle right here, the green one, is, here we go, a similar triangle to this triangle right here. And this theta are corresponding parts. In other words, if I take this triangle and I flip it this way, they are similar triangles. That means that theta actually resides right here along which axis?
The X. The Y.
Which one is it?
The Y.
The y-axis. Everybody tilted their head, right? This is y and this is x. It's in the wrong place. Do we like it around the y-axis? No, we don't. We have been taught to always put it on the x-axis. What that means is our component formulas, where we know that the x component is always cosine and the y component is always sine, is based on the fact that theta is on the x-axis, and it's not. So what I will tell you from this moment forward, every time there's an inclined plane problem, and only an inclined plane problem, I will say, remember, inclined planes are weird. Remember, the components on inclined planes are backwards. Remember, do a flip-flop, and this is the way we're going to write it. So when we do our x component, which is our parallel to gravity, instead of it being the force of gravity times cosine, it is instead the force of gravity times sine. We had to flip-flop because we flip-flopped where the angle was located. And when we do the force of gravity perpendicular, which is along the y-axis, it's going to be the force of gravity times the cosine of the angle. It only does this on inclined planes. It only does this when the angle is affiliated with the y-axis. All right, so what I want to do now is make a substitution. Up here in my net force, instead of Fg parallel, I'm going to substitute what that is equivalent to. And instead of Fg perpendicular, I'm going to make that substitution as well. So now I want to ask you a question. If we look at the sum of forces in the x direction, is there an extra force? Or is it balanced? It's balanced. So whenever there is no extra force, and for the sake of the person that's off screen right now, I'm going to write the formula here. Whenever there is no extra force, we know there is no acceleration. It's balanced. So in this case, our net force is 0 in the x direction because friction is balanced by the parallel component. In the y direction, would you tell me it is balanced or unbalanced? It's balanced. This box is not going to accelerate up or accelerate down. Therefore, this also, net force is 0, the acceleration would be 0. There's one other step that we're going to add to inflate these equations a little bit, but I'm going to do that on the next slide. Okay? We're going to do this all one more time. I'm going to take you step by step through it with a slightly different scenario. But do we have any questions on this slide before I go forward? Okay, let's try another one. Now we're going to have an inclined plane. With no friction. All right, so So you start. I want you to draw the inclined plane and your free body diagram on the inclined plane as best you can. Do the components with a different color, and then we'll pick up together. And you can draw the inclined plane facing left or facing right. I'm going to be consistent with you going uphill for the next couple of slides. And as you're finishing that up, I'm going to draw the diagram myself. How many forces did you have on your free body diagram?
Two.
Two. Good job. Remember, the components don't count as real forces. They are just a tool to solve the problem. All right, so from here, you're going to write your statements for your components, like what the components are equal to, and then start your net force equations. Yes, I purposely flipped it so you'd ask the question. Either one is fine. All right, check your components. Make sure your components look like my components. And then let me ask you a question. If I wanted to expand the formula a little bit on my components, does anybody know what FW is equal to? What variables are packed inside that weight force? What are they? Mass and gravity. That means I can expand this slightly. Instead of FW, I'm going to substitute in mg. And I'm going to do it again for the other component. Instead of FW, I'm going to substitute in mg. Please remember that the force of gravity and the force of weight are identical and interchangeable. So if you use Fg, that's fine. If you use FW, that's fine. All right, let's go forward into the net force. In the x direction, what is the only force I see? The parallel force, so we'll call it FW or FG parallel. Now it is pointing down the ramp. At this point, you have a decision that you can make. Either you're going to use a negative sign because it's going down the ramp and you're to the left and you're indicating that, or you can simply leave it positive and remember at the end that you need to designate a direction in some way. When we take a box and we sit it on an incline, it changes things. It makes our left and right and up and down a little bit offset. So sometimes it's better to just give a description at the end instead of just negative and positive. So we have that guy there. I'm going to make a substitution. The substitution for the parallel is mg sine theta. And that looks pretty good. So let's try Fy. The two forces I'm concerned about are which ones? Normal and gravity. I'm going to do normal minus the gravity because they are equal. Well, normal and the perpendicular gravity. And if these two forces are balanced, let's start there. If these two forces along the y-axis are balanced, what do you know the acceleration is? Zero. So I can simply say that that is now equal to 0. So I'm going to go ahead and expand this. I'm going to plug in for my perpendicular. Let's do that now. Fn minus the perpendicular, which is mg cosine theta, is equal to 0. Did I lose anybody with the 0? We're okay? So now I have another question. Along the x-axis, are we balanced or unbalanced?
Unbalanced.
Unbalanced. So for that reason, the object will accelerate. And which formula is going to help us find acceleration?
F equals ma.
F equals ma. My net force is also equal to ma. That means this net force in the x direction is also equal to ma. So I can say mg sine theta is equal to ma. And can I simplify that? I can cross out the mass on both sides. So then I can simply say that my acceleration is equal to g sine theta. So what I want to do here is call a couple of things to your attention. First of all, when I'm ready to plug in a number, when I'm plugging in, for instance, g, I'm probably going to just use the magnitude of g and not the negative. Because when I come back over to my free body, the free body is going to establish the direction for me for every single force. I don't have to get bogged down with negative. It's like downhill, not uphill. I can simply just look at the free body and reestablish what the direction is. The other thing that I want to call your attention to is I'm working out all the variables ahead of time, and you're going to use the same process even when you're given numbers and asked to find something, which we're going to do next. But please do the variables first. Now the third thing I want to say is this. After every force test in AP, I have about half the class come to me and say these words. I didn't do well on that test because I didn't memorize all the formulas. I needed to memorize all the formulas. And I say to them, there are not very many formulas to memorize. First of all, that green box right there, those are the only formulas for the whole unit. Okay? What they meant by that statement and what they mean from year to year is that they didn't do this process. The process is draw the free body diagram and look at it. And then you make a sum of forces statement. Every sum of forces statement for every situation is different. You can't memorize them all. But every time you can draw a free body, and every time you can look along the x and along the y, and you can do your sum of forces statements, and you have all the equations you need. It's just a matter of doing this process. Okay? Questions on this slide before I flip it? Yes, ma'am.
For the weight one that was parallel, you said it was positive and not negative because...
So the parallel component, when I look at it, it's going down the ramp. So what I would do is I would come up with just the magnitude, and then at the end I would write down the ramp instead of negative whatever. If you use negative, that's fine, but you have to understand that negative means down the ramp. Because if I had drawn my ramp the other way, things would have gotten weird. Yes, ma'am.
So with the sign, it's for for parallel, it's sine instead of cosine because it's
We had to flip-flop because of where that angle is located. The angle, the corresponding angle to what you're given is always located here along the y-axis. And because the angle's along the Y, then our conventional memorized formulas don't work. We have to flip-flop. Yes, ma'am?
So for inclined planes, always sine is gonna equal x-axis. Okay.
And it's only for inclined planes. It's because the angle's on the Y. Any other questions? Let's do a problem together. Let's make one up. A box slides down a frictionless ramp. I guess I need to give the mass, a box a mass. Let's do that. Let's say a 40-kilogram box. There we go. Slides down a frictionless ramp of 20 degrees. Find the normal force and the acceleration. That didn't need a question. Okay. You're going to go through the same process. Please do all the variables first and then plug in the numbers at the very end. And I'll check back with you in a second. All right, where's my lab?
So for the height, so you're gonna measure, like if you go to the atrium, then you should start here, the big stage, you're gonna up high, or the stairwell, drop it, and let it fall down. What would be best is somebody like, and she can text, and I'll let you know about that.
I do have a friend, but she's in the class in bear time.
I think you can ask, text her, and then I'll send a
Yeah.
email to her teacher too, or whatever, if
Okay,
you wanna do that.
She has
Chill.
cost.
Okay.
I'm in-
If I gave you like, you want me to send an email, you want an email, cross.
No, I'll get a sheet.
Only beans.
for a cross, but I need to email
that I
mine.
don't think.
Email me, email me, but you think you got cross savings zero?
Yes.
Okay, so let me give you the stuff you need. When you just put it out and measure, you're gonna bang that new one down and just roll it. Okay, here's you. And you gotta type it on your phone. You have a, like, right?
Okay. Guys. Hold
So like, you want me to do H and you wanna do it all the way down? Like from above the stairs?
Yeah, all the way to like with the floor downstairs.
So do you know how long
No,
it is?
you're gonna use the measuring tape.
How are we supposed to know G? Is that
Can-
what that is? I can't. There's no way.
Yeah.
What did you get?
That Y, A.
4.42 for the acceleration.
What did you get?
3.42.
I did not get that.
And the HER.
I got 13.6. So it's mass. Okay, how did you set up your equation?
I'll be right back.
So you didn't use that one? I did A equals
No,
G.
you didn't have to. You can use this.
Alright guys, I'm just
I
gonna
don't
start
know how to
drawing
do
the
that.
diagram, make sure we're on the same page.
I use these to find the parallel gravity.
Isn't it just the normal force of gravity? So
I know, and then once I found this, I just plugged it into F. So you can use this. It gets the same answer. I just did it on here too.
I didn't know how to use the other one. So. Wait, what does gravity equal? 10. Oh, that's probably why. I thought it was grams. Okay. Is this what you got? How did you get 10 for gravity?
You just like round it to 10 because it's.
Oh, it's
negative
negative
9.8.
one. Oh,
Yeah.
And then for Fn, let me do that one first. What am I something? For the X force thing, did you get 365? Minus
That's really
mass
close
is
to
40.
I got 375.
It's 40. 100. Cosine times. What'd you get for Fn?
I
Please.
got
I'm still getting 360. How did you get
106.
I'm putting the exact same things. Bro, I got 375 for FN. What'd you get? I haven't here done anything
You
else.
did see most find it all together. Let me do it.
You did cosine? How did you get 100? I got 300. That's funny. Yeah, this should be. Should we fix this? That should be sine. So it's not 100? Right? I got 375. I'm proud of you.
Yeah, I got 375 too.
Isn't it for FN?
Are you finding this to find normal?
What? Yeah, I'm just finding both X and Y.
No, I'm not talking about the X, I'm talking about this is the Y. This is the perpendicular gravity, so I can find out
Or
normal.
you switch them? Where's the... Or you parallel the Y? Then wouldn't... Does she have the answer on the board? No, she doesn't. Okay, so I got...
I'm sorry, Sir Ghost.
Gary, what'd you get for acceleration? Y negative. Oh, okay, and then what about the...
Okay, I circled this because I used it.
I got 375.
That's what I got. So if we're doing this wrong, we're doing it wrong together.
You're right. Teamwork.
Alright guys, so let me interject a little bit. Are we feeling okay about writing the components?
Yeah.
So now we're looking at our sum of forces in the X. The only force I see in the X is my parallel force. It's your decision whether you write it negative or positive. I'm going to go ahead and remind myself just not to forget that it's to the left or down the hill by using the negative sign there. Thinking about a number line to the right is positive and to the left is negative. Then I'm going to substitute what that is equal to. So my parallel force is equal to mg sine theta.
Negative. Okay.
And in the X direction, is it balanced or unbalanced?
Unbalanced.
Unbalanced. Therefore, it will accelerate. So I'm going to redraw this, or rewrite this rather, and that is going to equal ma, just like net force equals ma. I'm going to spend one more step simplifying it. I see there's a mass on each side. And I have this great expression here for acceleration. Acceleration equals negative g sine theta, and technically that negative is just reminding me that my acceleration is down the hill. I'm going to hold on that one for a minute. I'm going to go to my other sum of forces in the y direction. Now in the y direction, I'm going to take the normal minus the perpendicular. Then I'm going to plug in what I know it's equivalent to.
163
The normal
for the normal.
minus mg
No, 375.
cosine theta.
What are we doing?
And then I need to ask you, in the y direction, are we balanced or unbalanced?
She got 100.
Balanced. Therefore, my acceleration is
163.
0.
I don't think I
And my
did.
net force is
I don't
0.
know what I did.
So I'm going to write my normal force minus mg cosine theta is equal to 0.
300.
Well,
Okay,
it's supposed
yeah,
to be
yeah.
0. There we go.
Here, so
So that takes care of my two
40
equations.
times.
I'm going to go one more step. I'm going to isolate my normal force because I know normal
Oh, I
force is
spit on
what
my
I'm
paper.
looking for. I've done all the work. Now this is what we call plug and chug. You're going to take the values that you were given and put in for the relevant variables, and we're going to find our answer. So let's plug in g into this guy right here. I'm just going to use the magnitude of g, so that means my acceleration is equal to 10 times the sine of 20 degrees. I'm squeezing it in right there. Did anybody get an answer for me?
Negative 3.4. That's what I got.
Negative 3.4 sounds good. 3.4, and my unit is?
Meters per second squared.
Meters per second squared. Now when I write that negative, it is just fine for you to instead write 3.4 meters per second squared down the hill to the left, or
No,
something
it might
along
be
those
because
lines.
I didn't have any
Okay?
degrees.
So now I'm going to find my normal force.
Wow.
To find the normal force, I'm going to plug in a mass of 40 kilograms. The magnitude of my gravity, my gravitational acceleration, and then cosine of 20 degrees. What'd you get for your normal force?
375.9.
We'll call it 376.
Okay. That works. That
I don't know
works.
why it makes dots arbitrarily sometimes. I apologize.
Wow,
All right.
I get this.
That's a big one.
If it involves triangles, I get it. If it doesn't,
Okay.
I don't.
You did it.
So let's see.
That's the answer. If you want to put up, you can, but you can tell normal force is supporting the object. That's good enough because it's positive. So, Chimodi, I can get you to stop the recording, and then I can take any questions that we have right now. Yes,
So
ma'am.
if you'd set up the ramp, then it would have been positive. The acceleration. Okay.
Or you could say to the right.